Part C, we have 3 radical x plus 4 plus radical x plus 2. Now, these are not binomials that we're multiplying together because you can't have a square root of x in a polynomial or a binomial. But you still handle it the same way. You distribute every term in the first quantity to every term in the second quantity. It's still just a distribution law. We just have to use it more times. But since these kind of look like binomials, 3 radical x plus 4 looks like a binomial, right? It has 2 terms. It's not a binomial in the sense of a polynomial's definition, but it has 2 terms. And so does the square root of x plus 2. So you can use FOIL if you want. It'll work. First, outer, inner, last. So what do you get when you multiply the first term? Let's see if we can get the simplified product. Multiply the first terms together. What is 3 root x times root x, assuming x is non-negative? So if you think about it, if you take the square root of a times the square root of a, then isn't that the square root of a squared? Because you combine the radicals and multiply a times a underneath the radical. And if a is non-negative, the square root of a squared is just a. You would need absolute values around it if you don't know if a is positive or negative. So the general formula would be that. But if you know x is non-negative, you can drop the absolute values, or in this case, a. But back to the example, if you know x is non-negative, what's the square root of x times the square root of x? X. And then you still have the 3 attached to it, right? So the first terms multiply out to be 3x. That's the first. And then the outer, you're multiplying 3 times the square root of x times 2. 2 is outside of any radical. There's no radical there. And you can multiply unlike terms together all day long. So you multiply 3 radical x times 2, you're going to multiply the 3 and the 2 together. What's that going to give you? Including the operation, what are you going to have? Plus 6 times root x, right? Not 6x, but root x. So that's the outer from the FOIL method. That's the outer multiplications. Does everybody see that? What do you get for the inner multiplications? What's the operation? Plus 4 times square root of x. I just write it down. Does everybody see I'm just writing down the multiplication? It's 4. The inner multiplication is 4 times root x. I can't simplify that. I just write it down. And then what's the last multiplication? The 4 and the 2. What's the operation? Plus 8 on the end. That really is the FOIL method. Stare at that. We're not done because there's like terms, but stare at that for a second. Make sure that makes sense to you. Is that okay? What do you get when you combine together the 2 like terms in the middle, the 6 root x plus 4 root x? So 3x plus 10 root x plus 8. That's the best I can do. You cannot combine non-like terms together via addition or subtraction, right? You can multiply unlike terms together all day long. Have you ever played with a torque wrench? What are the units of a torque wrench? It's usually, a torque wrench is usually in like foot-pounds. Remember that? If you ever worked on a car and you play with a torque wrench, you probably wondered what a foot-pound is. Well, we're not going to get into it. It has to do with the definition of torque, but the definition of torque involves multiplying 2 unlike units together, feet and pounds. You can do that all day long. But you can't add or subtract unlike units. So you got to leave 3x plus 10 root x plus 8. None of those are like terms. Just leave it as is. The cubed root of b to the 4th times the 4th root of b cubed. What do you notice here? The indices are different. So that trick of combining into one big radical and multiplying the radicands, no, can't do it. What could you do? How could you rewrite the cubed root of b to the 4th? B to the what power? 4/3, right? That's this guy, right? What's this guy? B to the 3/4. You could use your knowledge now of rational exponents. And now, what does that look like? Which property? What are we doing? Same base. We're multiplying like bases. So you keep the base and do what? Add. So 4/3 plus 3/4. Oh, heck, we could do that as scratch work. 4/3 plus 3/4. What's the LCD? Okay, what do I got to multiply this first guy by? 4/4. This second guy? 3/3. So what do I get? I get, what, 16/12 from this first guy plus 9/12. So what do I get all together? 25/12. So I'd get b to the 25/12, which would simplify. So we should probably do that. So as a root, what is this really equal to? The 12th root, denominator is the index, and then b to the 25 underneath that root. We can certainly simplify that, right? What kind of powers do we look for? B to the, well, no, b to the, we want to look for perfect 12th powers, don't we? So we can take those out of the radical. So how would you, what's the next perfect 12th power down of b, down from b to the 25? B to the 24. So you could rewrite this as the 12th root of b to the 24 times what? B, and then what could you pull out? The 12th root of b to the 24th is b to the 24 over 12. It's b squared. So as a final answer, what could you write? B squared times the 12th root of b.